Hi, everyone. Welcome. I am Craig Conboy, the tech lead for Elastic Observability. And today we're going to look at some exciting innovations from elasticians working on the Elastic Observability solution. The ideas we're going to show you are in an early stage of their development. Too early for there to be a plan yet for when they would arrive in the product. So today is about showing the concepts and asking you for your feedback. Would you use a capability like this? What could we do to make it more useful for you? And I'll just say again, these are early ideas, no commitment yet for when these would show up in the product. It will all depend on your feedback. So without further ado, let's get into some of the ideas. Today, we're going to look at a new approach that could make alerting related to service level objectives much better. An idea for rotating logs that would improve the reliability of log collection, and a great way to observe the operations of your Cicd pipelines using and Elastic. So stick with us. This is going to be a lot of fun for us to share these ideas, and we are monitoring the chat. So feel free to add your comments and questions there. So first up, I'd like to introduce Dario. From the Elastic Observability team. Dario, welcome. Where are you today and what do you work on for Elastic?
Hey, Craig. I'm based out of the Netherlands, near Amsterdam. I am part of the observability group, of course. I work on APM, application performance monitoring, and I work mostly on the visualization side of things, so Kibana. And I spend most of my days thinking about what data do we have in Elasticsearch, and also how we can get it out of Elasticsearch again, to get our users the information they need to quickly troubleshoot their applications using Elastic APM.
Okay, great. Question of the day: sweet, salty, sour, spicy. What is a favorite flavor or taste?
I would have loved to say spicy, because it makes you sound like a badass. But if I'm going to be honest, yeah, it's going to be salty each and every day.
Finest mineral. All right, so could you tell us about service level objectives?
Yeah, sure. So a service level objective is it's a key component in measuring the reliability of your service. There are targets that you set based on measurements or indicators that we call service level indicators. For instance, you might measure the average response, and then you set a target for that API where the average response time should be below 100 milliseconds. That is the SLO. And the SLIs and the SLOs, they might be part of something bigger called the service license agreement, service level agreement, which is a contract with your users where not meeting the targets defined in the SLOs could result in financial penalties.
I see. So users, once they've defined these SLOs, they must want to keep a pretty close eye on how they're doing in attaining them.
Yeah, for sure. If you got good SLOs, you've got to also got the basis for great alerts. It can be all too easy to configure alerts that fire too often or too little, or too soon or too late. And with an SLO, you can set an error budget for a certain period. And that is how many errors you've left before you beat your SLO for the time period. And the rate at which the error budget is being consumed over the measure window is what we call the burn rate. And that's what we'll be alerting on. So as an experiment, me and my teammate Nathan Smith, we worked on a Kibana alerting templating language that allows users to express an SLO as a rule and alert on it as well. So let me share my screen for a quick demo.
Great, let's take a look.
So before we dive into what we've built, I want to quickly highlight what we have today as far as being able to customize metric-based rules and why we wanted to build what we did. I'll head over to the metrics app in Kibana to show you what users can and cannot do today. So let's try to create a metrics threshold rule. Now you can already see that there are a lot of options here. You can select multiple conditions. You can select the aggregation type, the field, the comparator function, different thresholds, different time windows. But for instance, what you can't do here is ratios. And that's what we need to calculate burn rate for the error budget. Ratios can be done with alerts in the logs tab in Kibana, but not the time window comparison we need. And to some extent, this is a choice. Giving the user every option that we can think of will inevitably lead to them becoming overwhelmed. We generally try to build more curated rules, which are easier to get started with. Still, we see a lot of our users asking for more customization options, which is why we wanted to experiment with a templating language that gives them just that. So for this concept, we built a page in the observability app where observability users can create rules via simple forms, but they can also edit the underlying generated template if they want something more custom. So for users of Elastic Security, this might look familiar because we took inspiration from their fantastic location UI. We built out simple forms for creating some of these oft-requested rules like SLOs or app score or alerting on new or missing data. Let's look at the SLO one. As you can see, you can configure the Elasticsearch index query, the grouping fields, the complete set of events to take into account, and the events that should be considered successful. And you can also set a target. Like you might want to set 3 nines, you might want to set 6 nines. But for the purpose of this demo, we'll set a slightly less ambitious target. And what we can do then is we can also convert it to freeform, and that will show you the underlying generated template. So as you can see, there's a bunch of setups here that we configured in the previous form, like the index query, the filter that's defined, the grouping field. What we also see here is the metrics that will be collected. So we're aggregating the events that were on target over a given time window, the total amount of events, and we're doing that over multiple time windows, 5 minutes, 30 minutes, 1 hour, et cetera, et cetera. And lastly, what we're doing is we're calculating the burn rate for each of those time windows by evaluating a mathematical expression. And finally, what we can do is we can configure the alerts themselves. So what you can see is that we're combining multiple time windows, 5 minutes, 1 hour, and 30 minutes and 6 hours. And that is to make sure that the alert itself doesn't fire too often or too quickly or recovers too late, etc. And the reason why we have different types of alerts is because, for instance, with a shorter time window, you might want to fire a Slack notification. Like if it's a bigger violation over a shorter time window, you might want to fire a Slack notification. If it's over a longer time window, but a less severe violation, you might want to open up a GitHub issue. So that's why we've configured different kind of alerts. And what we can also do is we can preview the rule to get an idea of what those metrics will look like, what those burn rates will look like. So for instance, we're now looking at the 1-day burn rate. We can also select the 1 hour burn rate. And if needed, we can tweak that a bit to make sure that the alerts that we set are not too noisy, that they don't fire too often. And the best part here is that if the user does end up wanting more customization, they can edit the template. They can change the time windows. They can change the target as well. They could write a completely different expression, whatever they want to. And again, this is just an experiment at this point, but I think it's a good indication of what kind of possibilities having such a templating language available to users will give us.
There's an easy out-of-the-box experience, and that you can also flip into custom mode and adapt it to exactly the needs of your business rules. That's amazing, and I love the preview part of it too, to sort of see how it's going to work. So where are we with this idea today?
So we're currently working on finalizing a project that will provide the building blocks for a feature like this. In a nutshell, this project will give users the ability to store alerts, apply workflows to these alerts, and also to create alerts on top of alerts. We obviously still need to figure out the UX. This is just a really rough exploration at this point. Cool.
All right. Well, we have a link coming up later where we can collect where if you like this idea, or there's something that we could do to make this more useful for you, you can let us know. We would appreciate that. Thanks, Dario. This is really exciting stuff. Thanks a lot for sharing it with us. Okay, thanks. Next up, I'd like to welcome Noemi from the Elastic Observability team. Noemi, welcome. Where are you today and what do you work on for Elastic?
Hi, Craig. Thanks for having me. I'm based in Budapest, Hungary, and I'm a software engineer in the data collection team of observability. I focus on the beat platform, file beat inputs, journal beat, function beat, and so on.
Okay. So question of the day. What's the favorite flavors? Sweet, salty, sour, spicy?
Spicy, anything spicy.
All right. So how does FileBeat deal with logs being rotated today?
At the moment, the log input of FileBeat can only cooperate with the create rotation strategy, where a new file is created on rotation and the archive files are renamed. The new file stream input has experimental support for copy truncate when the active file is first copied and then truncated. However, detecting the rotation events is just based on some kind of heuristics. We are doing our best to detect rotations, but there is only so much we can do.
What kind of things can go wrong?
There are a few cases when FileBeat cannot detect some rotation events. For example, users are rotating their log files too quickly, for example, every 15 minutes or every 5 megabytes of files. This means lots of new files show up on the disk very quickly, and the file system has to reuse previously encountered inodes. By default, we use inodes to identify files. So if FileBeat sees a new file, it believes that it has already shipped it or starts it reading from the wrong offset. It is also possible that an open file gets truncated silently, and then it gets updated with more contents than previously.
Okay, that makes sense to me at a high level. Could you walk us through that in a little bit more detail?
Sure, let's see an example for both problems. The first issue I mentioned is inode reuse. We have a log file named application.log. The log rotator is archiving it after its size 24 bytes and keeps only one archive file. Currently, it has the inode of 1 and its size is 1020 bytes. FileBeat, the orange box, has saved the progress into its registry. And you can see it has shipped 100 bytes to the output. The file is actively updated by the logger application. When it reaches the size limit, the rotator renames the file and the logger application opens a new file for logging. The inode of the archive file is still 1, only its name has changed to application.log.1. The inode of the new file is 2, and the new file is added to the registry of FileBeat, and the metadata of the old file is updated. And FileBeat ships more logs to the output. The active application.log has reached its size limit again, thus the previously archived file is removed and the active file is renamed. However, FileBeat could not forward all events to the output, so we have lost some logs. And the problem comes now, the active file gets the same inode as the previously deleted file. But FileBeat already has an entry for that in the registry. As the new file is bigger than the stored offset in the registry, the beat cannot detect the rotation event. Thus, it starts reading the new file from the incorrect offset. The second issue I mentioned is silent truncation. Let's assume we have the log file with the contents on the slide and FileBeat starts to read it. With gray, I marked the lines that were shipped to the output. You can see the offset in the registry in the top right corner. Now the file gets truncated by the log rotator because it is configured to use the copy truncate strategy, and before FileBeat could detect it, the file gets updated with new lines with more contents than it has previously forwarded to the output. The entry in the registry is not updated, so the beat tries to read it from the previous offset. But as you can see, the beat continues reading from the middle of a line. That is a mistake. FileBeat should have started from the beginning of the file. Unfortunately, these errors are extremely hard to diagnose because all we see is partial lines or parsing errors in FileBeat logs.
Okay, I can see that even though FileBeat is designed to support reading from rotating files, there are edge cases where problems can occur. So what is your idea for how to eliminate these kinds of errors?
Instead of playing a guessing game, FileBeat should take control of the rotation. If FileBeat does the rotation, it knows exactly which file has to be restarted and which file has to be continued from a previous offset.
Okay, so for people using log rotate today to manage their log files, would similar options be available to control when logs are rotated and what actions are taken on rotation?
I took inspiration from log rotate so there is plenty we can learn from the project. However, I do not want to provide the same support as log rotate does. We have to tailor our solution to the needs of Elastic users. So for example, I do not want to add support for emailing archive log files. My proof of concept does not contain much in that regard. It just renames and removes files. But if we hear from our users that they like this idea, I would like to add more features like compressing archive files.
Cool. Well, so is there a way for people to try this out, or if they have feedback for us, how would you like to get that?
Yes, I have a feature branch on GitHub. It is going to be shared in the slides. You can go ahead and build FileBeat and test it with your example configuration. And if you have any feedback, please open an issue on GitHub.
Great. Thanks so very much for sharing the idea with us today.
Thank you.
Okay, next up, I'd like to introduce Victor from the Elastic Observability team. Victor, welcome. Where are you today and what do you work on at Elastic?
Hello, Craig. Thank you. I'm this week in Spain, where I'm originally from, although I'll be traveling to the UK. That's where I live. So I work in the productivity team for the observability solution. And the aim of our team is helping our engineering teams to deliver faster and easier in an automated manner.
Okay, great. Well, so question of the day, sweet, salty, sour, spicy, what is a favorite flavor or taste?
After living in the UK for almost a decade, I'll say sweet and sour.
Okay. So what started you thinking about observability and CI/CD?
Good. Yeah, I'll answer the question, but first I would like to just give a brief summary what we do in the CI/CD spectrum at Elastic. So what we use is quite big, and I would like to illustrate a little bit with some figures. So we do have more than 30,000 Jenkins jobs that run 100,000 builds a week. What it means, we use more than 6,000 concurrent workers in parallel, that they basically do all the testing, all the releases and so on. What does it mean? That we need to support several different Jenkins controllers for different operating systems. Because everything is in source control, it's easy to track what things are rolling out and what they deliver new things. We know what happens, but because all the things are moving in a way like we don't know sometimes when there is a failure, how to debug, and it's quite reactive and time consuming, we realized that it really affects the speed to deliver new functionality. So the team I work with and I myself realized that we could use our own product at Elastic to basically be able to troubleshoot any problem with the CI/CD, to optimize the continuous delivery and continuous integration pipelines, and also, which is important, familiarize developers with the distributed tracing.
Okay, and what are the questions that people are trying to answer? The system.
Yeah, I'll say 3 of these questions are ones that we sometimes ask ourselves, such as when there is a continuous delivery or continuous integration pipeline fail, is there any particular service or third-party service that is a single point of failure? Are there any test executions that take the most time to be run? Or did the last deployment run all the integration tests before changing the configuration in the staging environment? So yeah, I believe observability can help to answer these questions using this distributed tracing.
Yeah, it's been very useful for our team to gain insight into what's happening in the CI/CD system. Could you show us what this looks like in action?
Sure, but before moving forward, I would like to explain just a little bit what we have done. We have engaged with the Jenkins, Ansible, Python, and Maven open source communities and built a few integrations to support distributed traces and metrics with OpenTelemetry. So those integrations help to visualize the software development processes in one single place. So let's now see how those integrations look like. The first one is integration with Jenkins and OpenTelemetry. Integration with Jenkins and OpenTelemetry, a way to visualize the continuous integration and delivery tasks running in Jenkins. So every Jenkins controller represents a service, so we can see the error bill rate easily. If we click in one of these services, we can see the recent jobs that were triggered. So every transaction represents a CI/CD pipeline. Errors are reported as centralized, so we can search for any particular bill error that happens in the CI. We can even go deeper in the distributed trace representation for a specific Jenkins build, which is a trace in this case. So let's select one that took a few minutes to be completed. Every single span that we see there represents a task in the CI/CD build. Finally, we can see all the representation for the third-party services that our CI/CD pipelines interact with. In this particular case, there is only one service at the moment. Integration with Maven and OpenTelemetry. Build automation tools are instrumented in order to send distributed traces. Let's see how it looks like for the Maven build tool. Every Maven project that we see there represents a transaction. So we click there, we can see the build life cycle for that particular trace. For instance, the span that does the clean of the build. So we click there, we can see the span and traces and transactions, and also the metadata. For instance, the Surefire Maven goal is another span that is represented there. Integration with PyTest and OpenTelemetry. In this example, we are going to visualize test execution with distributed traces. So our development process consists of some end-to-end test execution, and each scenario is represented as a transaction. If we click on one of them and select the trace that took a few minutes, then we can see all the spans that represent a step in the test execution. Integration with Ansible OpenTelemetry. This is the way we visualize distributed traces for the Ansible deployments. We can see all the transactions that represent the execution of every single Ansible playbook. Let's go to the Ansible playbook in charge of updating our dogfooding cluster. And there, we can see all the tasks that are represented as a span. Let's see one of them that install a particular tool. If we click on there, we can see all the metadata that is coming from Ansible, such as the argument for that task, the target machine, and results, and so on.
Victor, thanks. It was great to see Jenkins jobs, Maven projects, PyTest test executions, and Ansible deployments all made observable. Is there a way for people to try this out?
Yes. As I mentioned earlier, we have integrated with different tooling. They are mostly all of them public accessible. But I'll say the best way to talk about this, observing the CI/CD, is basically in the Jenkins CI GitHub repo that we are going to send and present later on the URL.
Great. Thank you very much, Victor. So thank you to all of today's guests for sharing their ideas with us. And thank you to all of you for tuning in. We really want to know what you think about these ideas. So please send us your feedback. You can use the QR codes below, or if you'll find links in the comments. Tell us what you think, what would make these ideas useful to you. And we appreciate your input to help us build a better Elastic Observability solution. Thank you.